Hey everyone, today we're going to have a talk about real numbers. Wait, well, why do we have to learn about real numbers anyway? Well, real numbers are the basis for math, and they allow us to understand problems and make sense of the world in different aspects. So we encounter and solve problems every single day, and many are not math related, but math helps us to develop logical thinking skills so that we can solve any problem. And numbers are the basis of this understanding. They're the basis of math. And today we're going to learn about the real number system. And our goal for today is to learn about different mathematical number systems. So I'd like you to grab your calculator, grab some colors, and let's get ready to rock and roll. Okay, so as we take a look here, you'll notice here we've got this nice Venn diagram-ish looking thing. And this is a great graphic organizer for us to understand the real number system. We're going to start off by taking a look at the most basic number system. And what I like to do is I make sure that my square root symbols are all the way over the number. So we're going to section these numbers off here. And we're going to label these natural or counting numbers. So if you think about Sesame Street and the count, he always counted 1, 2, 3. He never included 0. So if we look at this, 4 divided by 2 is 2, 6 is 6. And the square root of 25 is 5. We're going to learn all about square roots coming up in the next week or so. So natural numbers are always positive. So they're always positive. And they're always whole numbers. Now, the next section you'll see here are whole numbers. So whole numbers is the next section that you're going to see here. And so whole numbers include all of those natural numbers, but they have one extra addition, and the extra addition is the number 0. So the way I like to remember whole numbers is that the 0 and whole, it's really an O, but it looks like a 0. Whole numbers, 0 and whole, they include the number 0. So everything else, all positive numbers and 0. So there are no fractions or decimals. And only positive numbers. Only positive numbers. We haven't hit negatives yet. We can also put in this whole number, we can say, okay, well, 10 divided by 2, that would be a whole number because that simplifies to be 5. And that will also be a natural number as well. So we're going to build upon this. And we're going to move into integers. Integers is the next set of numbers that we need to know about. So integers are positive and negative whole numbers. We still haven't gotten into fractions yet. So they're positive and negative whole numbers. No decimals, no fractions. So think about this. Negative 3, that's a whole number. It doesn't have a fraction or a decimal attached to it. Negative 10 over 5, well, negative 10 divided by 5 is equal to negative 2. That's a whole number, and it's a negative number. Negative 4 is an integer as well. So we can also take a look at, let's say, the negative square root of 36. Well, 6 times 6 is 36. So the negative square root of 36 is negative 6. But we can also have positive numbers in here as well. So I can have 100 divided by 10. That's a positive 10. That's an integer as well. So both positive and negative whole numbers. We don't have any fractions or decimals yet. And keep in mind that natural or counting numbers are integers as well. So natural and counting numbers are nested in here as well, as are whole numbers. So if you take a look at this and think of it as like a nesting or a Venn diagram, natural numbers are whole numbers, natural numbers and whole numbers are integers as well, and then we get into our next number set because we haven't talked about decimals or fractions yet. So the next number set that we're going to take a look at are natural numbers. Okay, so what are natural numbers? Natural numbers are integers, so they're positive and negative whole numbers. They're fractions, so this is where we get into fractions. They're also repeating and terminating decimals. And we'll talk about that in just a moment. And they're whole numbers and counting numbers or natural numbers. So grab your calculator because now it's time. Counting and natural. Counting and natural numbers are used interchangeably. So let's check it out. So here we have a negative 2/3. Negative 2/3 is a fraction. But if you put negative 2/3 into your calculator, so 2, division sign, this means a division sign, 3, your answer will be, the decimal equivalent I should say, is 0.66 repeating. To show a decimal repeats, we put a line over the repeating number. This is what we would consider to be a repeating decimal. 1/2 simplifies to be 0.5. This is what we would consider to be a terminating decimal. Remember, 1 division sign 2 to turn it into a fraction. 0.37. If we take a look at 0.37, this is a terminating decimal. It ends. 0.37 ends. And we can also read this as 37/100. So this can be turned into a fraction as well. 0.3131, these dots mean that the number goes on and the 3-1 repeats as well. This would be considered a repeating decimal because the 3-1 repeats. So there you have it. Rational numbers are integers. I can easily say negative 49 divided by 7 is equal to negative 7. Negative 49 divided by 7 is a fraction. Negative 7 over 1 can be written as a fraction, so negative 7 and negative 49 over 7 are rational numbers. They're also integers. They're not whole numbers because negative 7 is a negative, so this is not a whole number. However, it is a rational number and it is an integer. So taking out your calculator again, our next group of numbers that we're going to take a look at are irrational numbers. Oops, I meant to use a highlighter on that, sorry. Are irrational numbers. Okay, so irrational numbers, these are what I call crazy numbers. They're not rational, but they are real. So everything we talked about so far are real numbers. They cannot be written as a fraction, and it's a decimal that does not repeat or terminate. So take out your calculator. I'm going to extend these square root symbols because that's important. So if we take a look and we take the square root of 10, first of all, this is a non-perfect square. And if you type in the square root of 10 on your calculator, and that would be the button that's just above the number 7, square root 10. If we look at that, we end up getting 3.1622766. On your calculator, your display only has a certain number of spaces to show the numbers. This number actually goes on and on and on forever and ever and ever. But we just don't see it, but it goes on forever. This is what we call a non-terminating decimal. So this is non-terminating. It doesn't repeat either, so that's why it's an irrational number. So pi, let's take a look at pi. Pi is one of the most famous irrational numbers. And we know that pi can be simplified, or I shouldn't say simplified, is approximately 3.141592654, so on and so forth. That's a non-repeating, non-terminating number, therefore it's irrational. This number right here that we have, 0.101, this number right here, this number right here, we know that the zeros and the ones, they repeat, but they're not a set pattern. This is a non-terminating, non-repeating number as well. So non-terminating, non-repeating, this goes on and on forever. This is why it's irrational as well. The negative square root of 123. First of all, this is not a perfect square. And when we put this into our calculator, we get approximately, and I say approximately because it's not going to be an exact number, 11.0905361. And this goes on and on forever. This is a non-repeating, non-terminating decimal. Let's take a look at the square root of 2/3. Again, this is a non-perfect square, so any non-perfect square is going to be an irrational number. And this simplifies to be 0.816496581, and this too goes on and on forever. So, to sum up irrational numbers, any non-perfect square, any number that cannot be written as a fraction or a terminating or repeating decimal will be an irrational number. All of these numbers, they make up the real number system. And it's really important to understand this real number system as we move forward in our mathematics careers, because a lot of problems that we solve will be based on the real number system. All right, guys, you rock. I hope you have an awesome day, and I will talk to you soon.